Let me see if I can open the Twitch app. Should all be fine. So my channel live. What did I want to do? I keep having stream manager, my channel. I keep having. I don't remember how to. I'm live, right? I'm live. Yeah. Stream manager. There you go. No. Here. No. Here. Share link to channel. Twitter. I just want to tweet that I'm live because otherwise nobody's coming. Cool. And I'm lazy, so just a standard message. Perfect. I've done a couple of things over Easter, but I'm a bit stacked because I have the feeling before Jordan kind of moved the whole thing into being a proper library, which I've, by the way, did a bit of cleanup and renamed things because it was like EHS because I originally used to call this whole thing entanglement hyperedge states simulator, which is just it's a bad name for that. It's just a bad name for that. It's entanglement hypergraph. It's entanglement hypergraph. That's what I'm doing, right? I'm building an entanglement hypergraph, and then I'm evolving it, right? And so it's a simulator on these. So I just kind of cleaned up things, but then I remembered I had the Proto V0, which was the notebook that I was building the prototype on. I had like, before this whole thing was moved into this shape, like I had another one that I just pulled in here in the project, which I renamed with like underscore alt, because I think that I was doing some work sort of after this refactoring, and now I don't really remember what was that I was doing. And this div view from VS Code doesn't help me either because it's not. Yeah, it's definitely not what like. I don't remember what I was doing. Even if I go and I take a look at let me see if I can take a look at the videos. I'm in studio. If I go and take a look at the videos that I recorded, so I did this video where I said we're now, I think, feature complete, right? I think it was this video. But then this video, we're feature complete, and I don't remember. So what is it like? Here I was just explaining stuff, I think, right? But what did I do after that? So this is I'll have to figure this out, I think, off stream, probably, because it's just going to take too much time for now. Because I'm totally lost in terms of, who, what did I really do? So there's something there that might be off that I did in the stream before, but I'll figure it out. So what I wanted to do today is I wanted to get rid of. Let me show you actually the whole. There's two things that we should do. Let me just show you first. Let's just open a terminal. I cleaned up the name of the environment folder stuff as well, just to use the standard thing. Instead of EHSIM, which was then conflicting with the name that I wanted the whole thing to have. And yeah, basically. So let me just start the Jupyter notebook because I can't, again, for some reason, get the VS Code editor for the notebook to actually use the right environment. I don't know why. And so two things. I implemented over Easter the whole rewriting rule mechanism, and I've tested it a bit, and it seems to work. but I haven't done the full cleanup. So I still would have to notebooks testing. This is the one that I wanted to go for. Let me just use. Let me just find things first of all. So this is the rewrite function, which basically does all the work for the rewriting. And there's a function that I need to implement correctly, which is not implemented correctly. It's the expand qubits function because it's not exactly doing what I needed to do. But let me see. So I'm thinking I want to use my other browser for these better. So there you go. Things are slow with Chrome. Things slow down with Chrome a lot. Like, I don't really, it just bothers me a lot. But anyway, there you go. So now we have this thing here. And so what did I do? I implemented the Harmat rule, the X rule, the swap, even the swap rule, right? Like, and the ZX rule. And I was just playing with some examples on how you would, how you would work with these, right? So you have these are the rules, and then, if I don't run any rule, then we have a simple system. Let this run a little bit. Then you have a simple system. Then the rules, what the rules do is they first they expand, right? They expand the rewrite. So they expand the mapped qubits, right? So the qubits that I'm going to apply the operation to, and then they actually run the rule replacement stuff. So they go through each of the edges because they should be considered as like separate systems, so to say, and check whether there's a matching, and if there's a matching, they replace the thing, and they also flag the thing that is replaced with a replaced flag. So I can then track what things have changed and show it nicely. But it also is not only showing it nicely, I also don't have to then worry about, rules doing some kind of conflicting behavior that was happening in the previous stream. That like if the X rules is like turn a 0 into 1 and a 1 into 0, and so both rules cannot get executed on the sort of the newly generated replaced nodes, because otherwise I keep, it does the full cycle from 0 to 1 and 1 to 0, and that's definitely not what we want to do. Cool. So this is the system, both qubits in the 0 state, and if I run the Harmat rule, then we see the Q0 now is in the plus state, and if we now run the CX rule, we see that we have two hyper edges. One is in the 1-1 state, another one is in the 0-0 state, and that is the correct Bell state. So all good. So this seems to work well. Now the only problem is that this works. I don't know. To be honest, why does it work? I thought it shouldn't work because the expand qubits doesn't do the right thing. But the expand qubits function is what this function should do is it should basically, and that's just a hack, but it should basically put all the qubits that we're going to operate on in the same branches and make sure that they are all in the Z bases. Because the idea is the rules are written in the Z bases. So this means the rules only need to be defined in terms of what do we do to the 0 state, what do we do to the 1 state. The reason this works in general is because of the linearity of quantum computing, so of the quantum mechanics part, right? This means that if I have a plus state and I want to apply a gate to this state, it's the same to apply this gate to the 0 component of it and to the 1 component of it, and then kind of have the full state of the system put together. So that's why it works. And this is still a bit of hacky because the only thing that it does is it it hacks it through, applying um, a double identity gate, which basically just puts the whole, all the things together. Um, yeah. So it's not, yeah, that's something that I want to get rid of, right? Because, and this is what's going to happen now, which is I want to get rid of the gates of the gates file. Like this is just history now. We don't want these because this is just the old gate stuff, right? So I'm just getting rid of these. Boom, delete. Now, now I need to make sure that this whole thing here still works. So let's go just through the code. I also, you know what? I think we'll just get rid of HyperNetX as well. I think it makes no sense at all. So requirements, it's just, oh, what did I just remove network X? Yeah, it's, do I need panda? Why do I need pandas? I don't think I need pandas, by the way. Why is there pandas here? Don't use pandas. I think I don't use pandas, but I'll leave it there. So, cool. We're not importing gates, we're not importing HyperNetX stuff because we're not going to draw things like that anymore because it just makes no sense. This drawing is expensive in terms of I got to map things out, and anyway, I end up using a visualization that is just the 2-column visualization, which is just, I don't like it because the cubes also get messed up and not in the same order. It's easy to get confused. So we are going to get rid of these completely. And what we're going to do is, I think I'm also not going to do the JSON stuff, by the way. We'll see. I don't know. Yeah, there's definitely a lot of bad practices in here, right? So, yeah, well, I don't need to use that anymore. I don't need to use the. I'm not so sure if I need to use these. I'll leave it there just in case. This is just a hack to give elements a unique ID as I create them. But am I using this anymore? Prefix and then, yeah, I'm not so sure this is so needed, but I'll just leave it there because I think it is whatever. So these things I might end up using some sort of helpers to one of the things that I want to do is I want to basically, when I display stuff, if it's one of the known states like the plus or the minus or the 0 or the 1, just print these things, right? Instead of the complex stuff, the complex numbers. And I think what I will do is I will just use these because I like them more. And then I do know that I have these rules, but these rules I'm going to keep them out of the library for the moment, just to keep the whole thing. So the 0 cat, the 1 cat, the plus cat, the minus cat. So this stays there. This is just get node labels, which is I think also not use anywhere. So I'm gonna just let's clean up. Let's just really clean up. Get h labels is also not used anywhere, just in the drawing function. All these are just helper functions. I'll probably just move them away somewhere else to make it a bit more clean. These are helper functions to move complex numbers to rectangular form or whatever, like the sort of the coordinate form versus the angular form. Good. Let's think about the renamings. Okay, so I also want to rename some of the classes for sure. I mean, nodes and hyper edges, I think, can stay the same. It's like I don't like to call this thing a hypergraph because it's just too generic. Node is node. Hyper. Let's do one thing at a time. Okay, let's just keep the renaming for later. So just I don't change too many things at once. And then we should clean out the to-dos as well. But this is the initialization, so that stays the same. Copy node, obviously it's not used at all. This is used. Get qubit node IDs. You know what? I think it's easier if I just know that what I should do is I should go to the apply gate and get rid of these. I don't need that anymore. I don't need to apply gates anymore. I combine edges stays there. Apply controlled operation also doesn't need to be there anymore because now we have rules. Because we have rules, it's easy. It's easy to just get rid of these things. By the way, if anyone has anyone watching has any questions, let me know. This is a bit of a more of a cleanup and then kind of thinking through, and we'll just maybe play with the system a little bit more, but just clean up the alt gate stuff. So if you have any questions on the chat or say anything, just feel free to use the chat. Apply control operations, that's alt stuff as well. So because now, as I said, we have the rules. So apply gate to node, I also don't need to use that. Apply 2-qubit gates, I also don't need to use that, And look, this is a lot of code. So this is just a lot of code, which I'm happy to get rid of. Yep. Can I just do these or like, let's just get rid of these. Oh, that feels so good. That feels so good. Get global phase is needed, and global phases, all this stuff is needed. And we'll actually be extending this soon as well, because I will be adding support for multiple dimensions. So for like registers, not just qubits, like, a register with 3 qubits or 4 qubits. And then we'll need to get that also give it a bit of an update. And global phase, correct phase, probably should give better namings. This is, yeah, state equal to state vector. That still makes sense. Factor recursive, this is really at the core of everything. So I'm also looking forward to actually test that a lot and then see if we can fix it, improve it. Delete edges, create edges, that might still be needed. Yeah, I remember this is a bit of a thing to kind of refresh in here. Factor phases, split edge Z. Am I using this anywhere? Where is this? And the measurement function. Okay, so. Oh, wait a second, but I think I might be able to reuse that for what I just, yeah, split edge Z, HUID qubit. That's, I think what this does is it actually exactly that's what I need the expand qubits to do, which is if I have an edge with like a plus state node, it splits the edge into 2 edges, one with a 0 and one with 1 component, which is what I want for the rules. The measurement, I think some of the stuff that I was fixing in the old prototype or working after the whole refactoring, I think they might be around the measurement. I don't know. Normalized edge amplitudes, post selection is also there. Yeah, okay, that was all stuff. I'll just get back to these. Expand qubits is the one to fix. Factor qubits. It's all really messy. Apply. Yeah, okay, so that was a function that Jordan had built that was just abstracting away the apply gate and apply 2-qubit gates, but we don't need that anymore. Print raw. And cytoscape export is something that I was playing with, exporting the whole thing in JSON. But I'm getting rid of that as well. Just getting rid of these. Because I think Jordan wanted to work on that. And is match, replace match. This is the newest stuff. Draw. So I'm also getting rid of these. So we'll just we will just use. I will just now quickly implement a printing, a printing that actually makes sense. So what are all these oranges things here? Okay, because this is searching stuff. And all this red stuff is, I guess, stuff that I've deleted. It's just the version control stuff. Question is, does it work? Doesn't it work? I don't know. Now, is this function used? And possible, yeah, these are all used, these functions, I think. Let's just print row. I don't want I want to get rid of all the prints because I don't know, I don't even know what they do anymore anyway. So call the recursive part. Man, that's gonna need a lot of testing. Print row. Okay, so it prints the nodes and the edges. And what I want to do, so I want to print a bit of in a matrix form, right? So what I want to do is I want to do, um, I wanna do it in a way like print. I think the best to do is as the number of qubits. So what grows the most is the number of edges. So the edges should be the rows, and the number of qubits should be, yeah, the qubits. Is there should be a come on, there should be like a something I can just copy from Stack Overflow or something. Something like uh, something like print, because what do I have? I have nodes. Yeah, okay, I have nodes and edges. But what I do, come on, that's just easy. I just go edge by edge and I print the nodes. I don't need to copy anything. Come on. I'm a big boy. So I go edge by edge and edge by edge, and what I do is I first print the so I first print the amplitude. It's, I don't know if amplitude is the right word, but amplitude, and then basically these, right? Cool. And then what I do is, and then I go for node ID in self edges edge node UIDs, right? And now I want to print. How do I know, by the way, how many qubits do I have? Because what I should do is in the hypergraph class, I should have self qubits, right? Which should just be a list of qubit labels, maybe qubit labels. And what I should do is this is the qubit. So what I should do is I should basically do self qubit labels, append, and I append these here. So this is for the qubit labels. Or if I'm in this mode, I'm creating the node here. So I'm doing the same with J here. So that should basically should give me the qubit labels, and then what I should do was, Jesus, snowing so much. I can't believe that. What I should do is in the print row function, it's the opposite. We'll not print the amplitudes first. We'll actually first go for QL in self qubit labels. We will just so we will print. Yeah, the thing is how to make sure that I print stuff spaced and not and all these kind of things. Like, yeah, I don't know. It's fine. I guess I have to get used to it. I to the fact that I'm just a noob with all this stuff. So I just need to I'll work on this off stream, but just to have something quick now. So I'll just print, or the other way around. It's just come on, print. That's easy stuff. That should be easy stuff. Print. Um, how do we do this in Python? So print array Python. Just in one line. There's a way you can just expand the whole list, right, and do something like this. Come on, that can't be that complicated. There's a Python array to string or something like this. Oh, there's a NumPy function for that, array to string, and I give it a list to a string. Oh, join. There you go. That's what I join list one. That's what I wanted to do. And I think I can give it. Wasn't I be able to give it some sort of what the separator is and all this kind of stuff? Oh, look at this. This does. Oh, that's the one that you're joining with. Okay. So if I do, you know, join, and we'll do just like, or just like a tab. Can I just do a tab here? Or whatever. String QL for QL in self qubit labels. So I should print the qubit labels, and then what I should do is for each edge, right? And each node, basically. Okay, but now I'll have the same issue that I cannot put everything in one row, but I can just say helper. So what I'm doing is, and I'm really, again, super noob at all this stuff, right? So I know it's really not quantum at the moment, but we'll get there in a second. So just trying to make sure I print it anyhow. So now I need to basically go and do p helper append, and what I want to append is self nodes with the node ID, and I want to get the state out of these. And basically, kind of after I'm done for each of the nodes inside this loop, I just print the whole thing. And what I should also do at the end is kind of copy the same and have a loop for the nodes which are not in so for e in self nodes for node ID in self nodes, then instead of these, what I do is if so these are the nodes which don't belong to any edge. If edge UID is none, then we add it to the p helper, and then we print the whole thing here again. So what we do is x x x x in p helper p helper p helper. So we're basically, so what we're doing is we're printing for all the edge and for each edge and then each of the nodes. Of course, that is assuming, you know what, I think that's also not an ideal representation. Because what I should do is, it can be that in an edge there's not a node, right? For a specific qubit. So that's just crap. That doesn't work. So what I should do is not like this. I should iterate and say for QL in self qubit labels, right? For each qubit, I should say now node ID, and I just like self get qubit node ID in edge. And who the hell knows what is the signature for that? It's qubit and the qubit edge. Okay. Qubit and the qubit edge. So it's QL and then the edge ID, which is basically E, right? So I'm getting the ID, and now what I say is like if the node ID is not none, then we just append that. Else we append basically something like these. Cool. Right? So I iterate over the qubit labels. I ask, is there a node ID for this qubit in this edge? So I also guarantee they're in the same order. And then if there's a node ID, then I get the state. If not, I apply. I do these. Cool. So I probably, and the same probably should be done here. So for all the nodes, basically what I do is I iterate over the qubit labels, and then I ask for, is there a qubit that's not in any hyperedge? Blah, 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 blah. If so, I get it. If not, I get rid of it. Now, well, that doesn't need this one then at all. So it's just these. So I just iterate over the qubit labels or none, and at the end I print the p helper. I don't know. Let's see if that will work. First of all, let's see if the whole thing will work at all, right? So I've got to probably just the first thing I have to do is I have to restart the kernel and clear the output. That's the first thing I have to do, because otherwise it won't catch the changes. Let's hope that I haven't deleted anything that it was crucial. We're not using the gates anymore. And again, we still have to fix the, okay, so does it count as, okay, there's an error. Okay, yeah, initial state, I assumed I should have changed that, yeah. I think I have to replace all the initial states by the zero cat. So I just do is hope that this works, zero cat replace all. And then also, I think there was excited, also excited state, and this will be the one cat. Cool. And then is there plus state anywhere? Minus state used anywhere? No. Okay, cool. Let's see. Clear output, clear output. Awesome. So what are we going to do right now? What did I do? Did I just restart this whole thing? Yeah, there we go. Okay, I imported it, so there's no funny errors there with at least not at the at sort of the code level. But let's see if you know, as we run this thing again, we are just, let me see first of all how the print looks like. Okay, so reference before assignment. Where is this happening? So yeah, maybe I should define it up here, not in the for loop, or why? I don't know. Oh, wait a second. Why? Where? In this line here. P helper. Oh, it's not initialized, but now it will be initialized here. And here I just for each edge, I think I'll just initialize this here again, and that's it. Cool, but not bad, not bad. Let's see. Okay, this is worked, and these. Oh, there you go. Okay, cool. So there's something obviously wrong here. What? So if we have one qubit, it's kind of fine, and if we, you know, applied Hadamard rule, it changes that. It's Q0. I need to get that precision. Oh, come on, I just deleted everything with the precision. I think there's a print. It's fine. This is basically probably the max that I'll get to, so okay, but why, if I do 2, why does it print first 1 then 2? I don't get that. Oh, that is definitely wrong. I think that goes here, right? That definitely goes here. Yeah, that definitely goes here. So if I will just even think about doing like, let me just do something like this. It's really ugly, but let's see if this works. I have to find a nicer way to print stuff. That's it, but I'll do that. Okay, yeah, that works. So it's qubit 0, qubit 1. Perfect. Perfect. Qubit 3. Yeah. So you know, prints kind of the whole thing here. So we give it 2 qubits. Cool. Now if we do this thing here, it should print 2 edges, but it doesn't work. Factor specific. Oh, look at these. Yeah, of course it doesn't work because now we don't have the expanding thing. Now let's get into that then. So because I was hacking, you know, I was kind of hacking around these. So now it's time to basically go to the expand qubits and figure out how to do this. So what we want to do here is we have 2 qubits, right? We have 2, so we give it 2 qubits, and the first thing that we want to do is we want to check whether these, what do we want to end up with? So we want to check, first of all, are these qubits sharing, or are these qubits anyhow in the same hyperedge, right? If so if they are sharing the same hyperedge, um, or by definition they're just not in any hyperedge, then it's just a splitting that we need to do. This means if they are not in the computational basis state, we need to kind of split these, right? If they are not sharing the edge, then I actually have to um, get them to the same edge, right? Yeah, exactly. And I probably now regret that I deleted the apply to qubit gate, because there I actually had code that I could reuse for these. It's a shame, and I'll probably have to just quickly go to GitHub and see if I can just, you know, copy it from there. Or better, I actually have it. No, 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 no. I actually have it in the notebook. I have it in this notebook, in the old notebook. I have it in the old notebook. If it opens. So if I go to apply to qubit gate. So okay, so that's what this is doing. So it's doing, even if one of the qubits is not entangled by the other, we add the qubit to all the corresponding edges before we start the operation. Sort of, yeah, it's like a sort of an expand actually. So I get the edge IDs of A and B. Um, then I'm adding the stuff in here. If both entangled but in different edges, we need to do some pre-processing as well. So you see, I'm happy that I then combine edges. From here on, we assume both are either not entangled or share the same edges. Cool. So I think that should, this part of the code, this part should do it. I can just copy that, I think. I think that's what I can just port to this function here. So let's try to make sure that this is what I think it does. So it takes the edges that A is in, the edges that B is in, and then what it does is it says, cool, if so if they're not empty, right? This means they're both entangled, but they're somewhere else. What we need to do is we need to do we basically need to kind of put them together, right? So A node IDs, so kind of need a bit of a product of those edges, so to say. So I get the nodes of A, and I basically, yeah, so what I do is I get the nodes of A, get qubit nodes of A, and then I recreate them within the edge, each edge of B. Then delete the original node. Yeah. So if oh no, this is okay. So this is if this is if A is not in any edge. That makes sense. If B is not in any edge, we do the same, but like we do the mirrored operation. Yeah. And if both are entangled, now that's the tricky part. Then we do the combine edges, and this is another function, another method which I fortunately kept here, which does this distribution that I talked about. Oh God, I'm happy that I didn't get rid of these. Okay, cool. So expand. Great. But these But these, right, it just expand qubits. Let's see what this does. Let's see what this does. Okay, so go to the notebook, clear output. Let's see what this does. Oh no, I can't actually test that because, well, oh no, actually I can test that. Yeah. But it's funny because if I need to test that, I need to make sure it works as well. Mm. So I basically need to give it a wave, maybe function to test that. If I how can I test that? How can I test that? Because it's not the whole thing. So it basically it tells me that it expands the whole thing, but now I need to know. So the nodes can still be, what was this function called? Split. The nodes can still be not in the computational pages. So split edge Z. What does it do? It's great that I didn't add a comment at these. So what it does is it takes a qubit and it gets the qubit node in an edge. Yeah. If this is none, it basically creates the edges. Exactly. Else it creates an edge for the zero component, one for the one component. Okay, so I got it there. That works. That's cool. That's nice. So this is there, and I should use that. So, but it needs an edge UID and a qubit, right? So what I should do, what expand should do, first of all, is after this is done. So after the uh, expand. So expand qubits. What expand qubits should do is first it expands them, and now we split. So what we now do is, well, we have qubits A and B, so we need to split both. So what we need to do is just split A, and then later basically repeat the same for split B. So I should basically do I should just kind of, redo these. And now do for HUID in HIDs. Basically expand qubits, and I give it the EID, and I give it the and I just give it the qubit, which is A, right? And so, and the same, I think that should be it, to be honest, that we do for B. Now, well, I don't know. Like if the length of these, right, is different than 0, then we do that definitely. Else we just expand on none, because we know that we're in no hyperedge. Exactly. The same here. So if length of the BHIDs, well, BHIDs is none, is it's different than 0, then we do this thing, else we do this thing. So that should actually be it, to be honest. But let's test that, okay? So it's for sure not going to work. But we have expand qubits. So, and we have the rewrite function. The first thing that it should do is it should expand the qubits. That's what it's doing here. Okay, cool. Now, let's see what happens, okay? So let's do a simple test, which is a really simple test actually, which is basically we'll put a one single qubit into the Hadamard state, so it's in the plus state, and then we will basically run a NOT gate, and this NOT gate actually should really split the edges, right? Because should split the edges, and we should end up with two edges. Let's see what happens. Because that's a bit of an edge case, to be honest, because then you have basically, yeah, we'll see. Let's see what happens. Okay, let's see what happens. We'll spend the rest of the probably like 15 more minutes or something testing around. So unless anything broke here, no. Okay, so let's do the simple test, which is basically we do a hypergraph. So we create a hypergraph with just one node, with just one qubit, and we apply Hadamard rule. Does this work at all? That works. Cool. Now we apply the X rule, right? What is this going to do? To be honest, it shouldn't do anything, right? But it should, well, let's see. Let's try to see what the code is doing. I mean, that is kind of correct, right? But I want to know whether internally it's doing the right thing. So expanding the qubits, they're definitely in, in none of these cases, but they are in these cases here, expand qubits. So what does expand qubit do? Yeah. Wait a second. Oh, that is actually what am I doing? This is not this. This is what? This is split edge Z. Come on. How did that even work? How did that even work? Nobody knows. But I must just, well, what is splitting edge doing? If I tell it this no, if it's none, it creates the two hyper edges. Yeah, that's with one ket and with zero ket. But it's not going to do any self-merging at the end, right? No, correct. So that should, I fear something's not being properly run here. So, am I getting here at all? Splitting, old school testing, splitting qubit, run all. Did this just, cool, so it's not getting there. I like that. Okay, so it's not getting there. So def expand. That's why it worked before. Okay, I'm here. So is it getting in here at all or what? Split A. Split B. Mm. Oh, okay. So actually that's a funny thing, right? So expand qubits, but there's only one qubit. So how does this work? Of course, it might not get there. Expand qubits, so rewrite. Rewrite. So, of course, it does not get there because it doesn't even call expand qubits. Like expand qubits, like if I only have a qubit, then it should not expand it, right? It but it should split it. That's a good catch. That's a good catch. So if the length of the input map is just one, you know, else I should choose these. I know it's wrong, but like I have to catch for all the cases. But if it's mm, yeah, but I can't just call. Yeah, well, if it's just one qubit, it's gonna be none. So then we know it's self. Then we know it's self split edge, and it's the edge UID. Oh, it pops up actually. The edge UID, which is none, and the qubit, which is FQ basically. So that's that. Nah, that should make it work. But it's a bit of an edge case I have to be because it's what did I do? Did I okay. So some things here are not working well. Rewrite X rule, that's the expected place where this is gonna hit. And so here is basically, well, yeah, there's no, so there's no, of course, this is it's, yeah. So are these lines the correct 525? 425. There you go. So get node ID in Etch. Hmm. But that should work, right? Because it's get qubit node ID in Edge. That's going to be tricky to debug. There's a lot of things intertwined in here. So, oh, it returns none if it doesn't find it. What? If the Edge UID is none, no, but if the Edge UID is none and the Edge UID is none, then return the node's UID, right? So if, okay. So none, it means it really didn't find it there, which kind of worries me because it means we're at line 400, 427, right? 400, which means that after the Hadamard gate, yeah, actually it is in a branch. What? What's wrong here? Okay, even that doesn't work correctly, right? Because it's creating 3 branches? What? Yeah, well, that doesn't work as expected. Okay, there's quite some more work to do here. So, and I sadly have to leave it here. I think um, it's, yeah. Why? Why is that creating more branches? So um, what if I just print length of system edges 2, 2 nodes. Okay, I really bumped into an edge case here. But we'll work on this tomorrow, I guess. But it's okay. So there's something off in the way this is working, right? So it's creating 2 edges. So if I go here and the rewrite, so just so I can read these. So we've just got a qubit, right? And so it's going and it's splitting the stuff. Yeah, that's why it's creating. That's why I'm not really happy with these. That's not true. That's definitely not true. What I should do, what I should do, but what I should basically do is I should go and say, yeah, so node ID self get qubit node IDs, get qubit node IDs, right? That's for the first thing. First things first. And I give it the qubit, which is basically FQ. And so now I say for node ID in node IDs, now I have the node, right, which is basically self nodes node ID. And now I can say, now I can split it. So I can say split edge Z, and I give it the edge ID, which is basically node edge UID, node edge UID, and the qubit, which is basically node qubit, but it's also we know it's the FQ, right? I think that's better. That's definitely better, but it's still when there's a single qubit in here, right? If the edge ID is known, it creates 2 nodes for the one component. And then create an edge for the one component for the kit1 component. Um, for the one component, and then we add the edge. Then create an edge for the 0 component. Recreate the nodes of A inside the new edge. Update the current edge to reflect the 1 component. One cat. Let's see what this does. Does this change at all anything? So because this basically, you give it a qubit, and if that's not there, then it should create 2 edges, right? Which is fine. It just, these edges can be merged afterwards. But this edge case I had never thought of, to be honest, the one single qubit case. But we'll get there. I have to work through all these edge cases one by one, 1 qubit, 2 qubits, 3 qubits, and then eventually we'll get there. So, but I think the structure is roughly the right one. So edge 706, really? 706. Qubit, get qubit node ID. That's the wrong function. Get qubit node IDs. That's what I want. That's what I want. But yeah, I'll basically kind of run out of time for the session today. Yeah, quite a lot of people watch this. I'm pretty happy with these. Okay, cool. But it's so I don't know why this NA is printed at the end, but this makes sense. Actually, this makes pretty much sense. You have 2 branches, one in the 0 state, one in the 1 state. No, that makes no sense at all. That makes no sense at all. Why do we still have one floating? That makes no sense at all. But it's not breaking, so now it works. I just have to figure out where the issue is. What have I done today? Yeah, I got rid of the linear algebra stuff, but nothing's working, so that's fine next time. So I got rid of these and worked on the expand qubits one just by copy pasting the code. And all these, I promise, will make much more sense once I get it all together. I promise. Cool. Yeah, thanks a lot for watching, and stay tuned for more. As you know, this is getting into a nice state where I feel that now at least the code is much cleaner. It's shorter, it's smaller, and yeah, basically the the execution of the gates is just way more consistent, and it's it's just one model. I'm not mixing linear algebra and non-linear algebra stuff. Just need to get the splitting here correct, the splitting right, and yeah, awesome. See you next time.